Hello everyone, welcome to the second video of the Attacking EKS Kubernetes Cluster series, where we'll look at how we can attack and defend EKS clusters, but this will be applicable to any other Kubernetes deployments, be it on-prem or other clouds. In this video, we'll look into basically Kubernetes basics to make sure we understand what we're working with. We'll look into what AWS will take care of us when it comes to EKS clusters, and different ways permissions can be assigned to pods, as those often interact with other services in the AWS, and those permissions can be exploited, as you'll see in later videos. So it's important to understand those. I will also look at some basic commands that are useful to work with the cluster and do some enumeration, but more can be found on official Kubernetes website if that will not be enough for you, but I think it will cover like 80% of what we'll use. I also terraformed all the entire deployment of the cluster. So if you just want to go back to the same GitHub, clone it, go to this folder, and follow instructions, you can just create the lab very easily with Terraform apply. Usually takes about 15 minutes. But you could easily spin it up and down to follow along. I already did that because it takes about 15 minutes. I already have access to the cluster. Let me make sure it's still up. Yep, we still have our nodes, so yeah. All right, let me share the diagram inside of Canva. It should be seen. All right. So yeah, let's explain Kubernetes basics and some of these AWS components. So essentially here we have a diagram from Kubernetes website. This is the cluster and its components. Essentially what we have is control plane, which is the brain of the operations and consists of the API server that's responsible for authentication, authorization, and basically main point of contact. This is how we interact with the cluster. It can be configured to anonymous authentication, but hoping you don't see it this often. But essentially, we come to the API server, we authenticate, checks our authorization, what we can do, and that handles all requests. Then we have a scheduler that schedules all the deployments. We have etcd database that keeps track of all the cluster configs, and we also have controller manager that keeps an eye on all the pods and makes sure they're running and they're in the desired state. So then we have two nodes here on the diagram. Essentially, nodes are virtual machines. They're running all the workloads. Each node has a kubelet. This is what performs all the actions initiated by the control plane, such as schedule a pod, adding a workload, or increase number of replicas. Basically, it carries out all the instructions. It reads etcd and carries out all the instructions. Basically, essentially, it's just a worker that does all the work, and control plane is the brain. Then I have a pod. Pods can run one or more containers depending on the design, but it's essentially just a logical wrapper to make sure containers can communicate with each other. Pods also have service accounts, which we'll look into later, but those are used to authenticate to the API server because we're using kubelet, not kubelet, we're using kubectl to authenticate and get authorization to talk with the API server. But nodes need to do that as well, so essentially, and pods. So pods have service accounts. Those are like essentially they use a JWT token to talk to API server, and we'll look into that more later again. Now let's see what AWS takes care of for us. Because we're in the cloud, control plane components are hidden from us. AWS manages that, which is kind of nice. The updates also taken care of by AWS, and scaling of control plane components. Essentially, you can have multiple control planes, same as nodes, to make sure those don't go down. And AWS is gonna handle all the control plane scaling to make sure we have enough managers and kube API servers. Now, because we're in the cloud, there are different and resources sometimes need to interact with each other. For example, a pod using the service account needs to talk to an S3 bucket or a database. Essentially, you can assign IAM roles to pods, and there are different ways to do this. So essentially, we have three main ways. First one is the legacy approach, which essentially is going to query the EC2 node instance profiles, basically IMDS, instance metadata service, on this node because it's just an EC2 instance. So this is the default. You just query the role that's associated with the entire node, but this is very vulnerable and old school way of doing it, because then every pod, it's not granular, every pod can interact with the same identity and get the same permissions. So that's not used too often, but I think in the future we'll look into exploiting this. And we have IAM roles for service accounts. IRSA, this is very complex and uses OpenID Connect. If you're familiar with it, I'm not too familiar with OpenID Connect to be honest, so we'll not look into setting this up. And the most smart way is EKS pod identities. So it was launched in late 2023, and this is the main way you assign identities to pods. Essentially, you can just map an IAM identity to a service account, and it's very easy to do. We'll look into how it's done. And if you compromise the pod and the service account, you essentially have IAM access to AWS, and you can interact with various AWS services. So yeah, that's all about explanation of Kubernetes cluster workloads, how it all works, and what EKS handles for us when we're in AWS, and some of the main authentication methods for our pods when we want them to interact with different AWS services. All right, now let's move on to some basic concepts and commands. If my VM will work, hopefully. So essentially, I'll show some basic commands that will be very handy to interact with a cluster and do some enumeration. So first one is we need to know what cluster we're actually using, because there could be multiple clusters set up. And for that, we use kubectl config get-context. And as you can see, I have like 4 clusters here, but the one we're using, the current one, is flagged with the asterisk. So this is the one we're using right now. But we can also change context if we want to, using this command. And here we just give it the name. So for example, minikube or currency cluster, and it's going to go into a different cluster. That's just in case you're pen testing or doing a security assessment of multiple clusters. It's handy to switch between those. Next one is listing all namespaces. These are essentially folders, and we can have different permissions across different namespaces. kubectl get namespaces will give us all the namespaces in the current cluster. Oh, I misspelled it. So these are essentially the default ones that are created by default, but usually have a lot more namespaces and these folders. And we'll create more in the future labs and in the future videos, and we'll see how different namespaces can have different permissions. I'll even show it later in this video in a few more commands down. So next important command is of course our permissions. What can we actually do? And this one goes like this: kubectl auth can I list. So that's gonna give us all the permissions we have. Because we're admin, Kubernetes admin here, we have access to every resource, and verb means asterisk. Essentially, we can do anything. But we'll see later when we get access to a service account or less privileged Kubernetes account, we'll see that we have less permissions. As I mentioned before, it's important to enumerate all namespaces, so we can do it like this. Let's follow namespaces using -n flag. For example, let's do kube public. It's going to be the same permissions because we're still admin, but still, just to show you that sometimes we need to specify different namespaces because we can have different permissions in different namespaces. to here, but we can see that we have the same level of permissions because again, we're admin. And the last important commands are listing nodes and pods. Same thing here, we need to make sure we enumerate all namespaces. For example, here we get all the nodes. Oh, I misspelled the command. Wait. That's just to know how many virtual machines there are and which one we're working with. Usually, actually not usually, always, we don't have to specify namespaces here, like because we just query all nodes with this command if we have the permission, of course. And last one is pods. This is essentially what holds our containers. And you can do it like this. Right now we can see that we have no pods in the default namespace, but as I mentioned, support to enumerate all namespaces. So if we specify system namespace, we can see that we actually have multiple pods running here. So that's why it's important to specify multiple namespaces. So yeah, these are going to be the main commands we'll be working with outside of course, AWS commands that we'll be using. But yeah, that's it for this video. Hopefully it was useful. You guys learned something about AKS clusters when you're on Kubernetes in AWS, different permissions. Don't forget to run Terraform destroy if you're following along. And in next video, we'll start looking at the attack scenarios. Stay tuned, and I'll see you in next one. Bye.